Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the O-level mathematics subject of binomial theorem for negative integers. So let's just start with 1 over x plus 1. So what we can just see by basic algebra is that 1 over x plus 1 equals 1 minus x plus x squared minus x cubed plus x4 minus x5. Why can we see that? We can see that because if we just multiply both sides by x plus 1, then if you multiply these two together, you're just going to get 1, because 1 times 1 is 1, and then you get like plus x minus x, then you get like minus x squared plus x squared, then you get minus x cubed plus x cubed. They all cancel, we just get left with 1. It's really pretty. So basically 1 over x plus 1 equals this, and it's an infinite series, and this only makes sense if the modulus or the kind of absolute value of x is less than 1, because then these terms are getting smaller and smaller and it's converging. But like if say if x was 10, these terms are getting bigger and bigger. It doesn't make any sense. We can also just substitute minus y in for x in the above, and you get a different equation. 1 over 1 minus y equals 1 plus y squared plus y cubed. Again, this is only working if the magnitude of y is less than 1. And actually this is the geometric progression equation. This is just a geometric progression. So initial term is 1, common ratio is y, and that's why we've got a previous video on this. That's why the formula is initial term over 1 minus the common ratio. So it's the geometric progression formula, really. All these things fit together. That's how maths should be. So we're going to substitute 3y here for x. So in this case, the magnitude of y has to be less than a third to make the magnitude of 3y less than 1. So 1 over 1 plus 3y is 1 minus 3y plus 9y squared minus 27y cubed, etc., etc. So let's do something more complicated. 1 plus x to the power minus 4. So we already know that 1 plus x to the 4 is 1 plus 4x plus 4 times 3 over 2x squared plus 4 times 3 times 2 over 3 times 2 over x cubed, and so on. Well, not and so on, because this actually terminates. This only has 5 terms. This is the standard binomial equation for a positive integer. If we got a negative integer, it's an infinite series, and so it goes 1 minus the power times x plus the power times the power minus 1 over 2 times x squared plus the power times the power minus 1 times the power minus 2 over 3 factorial times x cubed plus so on, so on, so on. It's an infinite series. That's how it works. But it's basically the same pattern as the normal binomial theorem. Here's a more challenging one. 1 plus 3x to the minus 5. So in this case, same process. We just do 1, and then it's the power times 3x, which is minus 15x. Then the power minus 1 over 2 times 3x squared, which is going to be 9. So it's 9 times 15, which is 135. Plus the power minus 1, power minus 2 over 3 factorial. Then it's 3x cubed, and so on, and so on. I hope you liked this video. I really liked making it. Please subscribe and hit the notification bell. You're very welcome. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics. For those that have stayed beyond the credits, I would ask you, how do you prove this? This is what my children say is post-credit scene. How do you prove? Because we know how to prove geometric progressions. We've done that. We know how to prove the binomial theorem for positive integers. How do you prove it for negative integers? I worked it out today. I think it's Maclaurin series or Taylor series is what they're called. If you haven't come across that, don't worry. But look out for it in the future. It's interesting. Beautiful, beautiful, beautiful. It basically says, for a large class of curves, they're completely determined if you know all of their derivatives at a given point. I hope you've enjoyed this. Love to hear more ideas. See you soon.